Now that you have covered the basics, it is time to turn this knowledge into a practical solution. If you need to, simply reopen the same scene file without saving the changes. As you look at your animated scene, you need to keep an analytical eye on the various components that define it. You have the vault itself, that is pretty much acting as a backplate. Nothing lies beyond it, and the camera is hardly even getting close to that area. Then you have the animated security door that is between your point of view and the vault. Finally, you have the animated arm that is part of the first-person perspective, and that partially covers the door between frames 120 and 200. It is important to define this concept of what is in front and what is in back as you plan your render passes. In this case, it is clear that the order is vault, door, arm, from back to front. And so, you will plan your render passes accordingly. Make sure the state sets floater is visible. As explained earlier, there is one default state set visible at this stage that is named State 01. Rename the existing state set Vault. To define this state set, click the Record button. As the state set is meant for the vault only, you need to hide all other objects in the scene. Choose the arm selection set and hide the selection. Similarly, choose the security door selection set and hide that selection. Also make sure the camera view is active, as this is the point of view you want to render. At this point, if you test render the scene, you get a rendering of the vault alone using the currently active scanline renderer. Obviously, you want to render the full sequence and not just one frame, but we'll get to that in a moment. First, notice the render contains all sorts of information from color to lighting to shadow, even self-illuminated materials on the computer screens. This is known as a beauty pass, but in compositing, you often want to separate that information for better control. In this example, and for the purpose of clarity, you will extract only the self-illumination channel separately, so that you can further manipulate it. With record mode still enabled, go to the Render dialog. Go to the Render Elements tab, and then click the Add button. Lower in the list, select Self-Illumination and click OK. This adds self-illumination as a separate render pass. If you test render your camera view now, this means that in addition to the beauty pass, you get a separate image defining self-illuminated areas. This can be used in post to make those areas glow brighter. Go back to the Common tab and set the time output to Active Time Segment. This ensures you render the whole animation and not one single frame. Ensure one last time that the camera view is active, and then exit Record mode. You can also dismiss the Render dialog for now. You can leave the result at that and be satisfied with it, but no render is really complete without an ambient occlusion pass. Ambient occlusion can go a long way to enhance rendering. There are many ways to produce ambient occlusion effects, some of which are covered in other tutorials on this channel. Here, you will use a very quick and easy setup to achieve an ambient occlusion, or AO, pass using the Quicksilver renderer. Create a new state set and name it Vault AO. Notice that if you set it active, you go back to your original scene where all objects are showing. Click the Record button on the new state set. Hide the objects you don't need, namely the arm and the security door. So far, the procedure is similar to what you did earlier, but you're about to change that. To create an ambient occlusion effect, you need to apply a white material to all objects. Select all objects and go to the Slate Material Editor. Create a new standard material. Make it white and 100% self-illuminated, and apply it to all scene objects. Dismiss the material editor. The camera view turns fully white, preventing you from seeing anything of substance. This is normal, as all objects are fully self-illuminated. Turn the viewport from shaded to a realistic mode. Now you begin to see something. Ambient occlusion works by adding contrast where surfaces come close together at a certain angle. By using this black and white information in post, you can enhance a rendering quite extensively. The trick, of course, is to render out such a map. At this time, the scanline renderer cannot help you. You need to use the Quicksilver renderer, a hardware renderer that enables you to render what you basically see in the viewport. Go to the Render dialog. Before you change renderers, go to the Render Elements tab and disable Render Elements passes. The self-illumination pass for the computer screen and the fluorescent tubes is already part of a different state set, and you don't need it here. Go back to the Common tab and switch the renderer from Scanline to Quicksilver Hardware Renderer. Next, go to the Renderer tab. With Quicksilver, you can define rendering time by either a number of iterations or by specifying a fixed time. Time is easier to predict, and for this example, 3 seconds should be more than enough for our needs. Lower in the panel, you can define what you want to render out. You won't need to render out shadows, but you do need ambient occlusion. The intensity fade value controls the contrast between light and dark areas. Set it to 1.5 for now, but you can experiment with this value if you want. The radius value controls the spread of the dark areas. This again is a bit of trial and error. Set it between 10 to 12 for now. Test render the camera view again. You get a nice black and white image that you can use to great effect in post. When composited, it adds depth and richness to your beauty pass. Go back to the Common tab and set the output to active time segment. Close the Render dialog, ensure the camera viewer is active, and exit Record mode. Press Ctrl D to deselect all scene objects. Switch back and forth between active state sets and notice the differences. In one, you get color information in a shaded view. In another, you get ambient occlusion information in a realistic viewport. The two state sets are also using two different renderers, and one state is set up to render a separate self-illumination pass. You have now completed state sets to take care of the rendering of the vault that is acting as a backplate. In the next movie, you complete state sets definition for the security doors and the animated arm.